My name is Rachel Bergman, and I am a member of the faculty lecture series that sponsors these wonderful events. So welcome to all of you here in person, and welcome to those of you who are streaming from the comfort of your home or wherever else you happen to be. We're glad to have you with us. I would like to especially thank the Thickman Lecture Endowment, and I see Dr. Cy Thickman is here in the audience, and I know you try to be at as many of these as you can, which is wonderful. The Thickman Lecture Endowment is what allows us to do this wonderful series. So we thank you for your generous contribution. The Sheridan College Faculty Lecture Series is designed to bring the scholarly expertise of Sheridan College to the community. And it's been funded by contributions to the College Foundation from Muriel and Cy Thickman since 2007. So thank you, we're very grateful. I'm going to just share a brief bio of our speaker tonight, and then you can help me welcome her to the stage. And afterwards, for those of you who are here in person, we will have refreshments. We will also have a Q&A at the end, so be keeping your questions in mind for the end of the lecture. So Dr. Rachel Kristiansen, a Sheridan native, is a full-time tenured faculty member here at Sheridan College in the psychology department. She received her PhD in experimental psychology from the University of Southern Mississippi in 2011. During her graduate career, she studied various species of cetaceans, dolphins, and whales in the Gulf of Mexico, Caribbean, Atlantic Ocean, and Pacific Ocean. And she served as a research assistant in several projects with small primates. Her doctoral dissertation examined a factorial analysis of personality in horses across the globe. Publications of her research may be found in peer-reviewed journals such as Zoo Biology, the International Journal of Comparative Psychology, and the Encyclopedia of Animal Behavior and Cognition. In 2017, she completed a master's degree in veterinary sciences with a focus on animal shelter medicine from the University of Florida, as well as a graduate certificate in nonprofit leadership. She's a busy person. She currently serves as the animal care director for Second Chance Sheridan Cat Rescue. So very impressive resume. I have been to a number of Rachel's talks, Dr. Kristiansen's talks, and they are all fabulous and engaging, and I learned so much, and I'm sure you will feel the same after tonight's lecture. So please help me welcome to the stage Dr. Rachel Kristiansen for Why is Stress Such a Pain in the Neck?
Thank you, Rachel. Thank you all for being here tonight. It's lovely to see you. All right, so for those of you who have been to some of my talks before, I alternate between having a talk on animals and then a talk on humans. This is a talk on humans, but of course the pictures must be animal themed. When I was trying to pick a topic for this lecture, I kind of was going through what are my students' favorite lectures that I give in different areas of my classes that I teach, and stress is always a hot topic because everyone experiences stress. We're all very familiar with the feeling of worry and anxiety and just being stressed. So today I just want to talk to you a little bit about what we mean by stress in psychology. We're going to look at some of the physical effects of stress on the body, some of the mental effects, and then we will talk about ways to manage stress. So I guess I will forewarn you that the discussion of the effects of stress on your body are very stressful. I don't want you to panic that your stress is going to give you a heart attack when you leave tonight, but you do need to be aware of the damaging effects of stress, but we will talk at the end of on ways that you can manage this. So when we talk about a stressor, things that stress us out, essentially this is just a challenge. It is something that you view as a challenge to a goal that you might have, something that you want to accomplish, or it could be a threat to you, something that makes you fear for your safety or your life. And there's a lot of different ways that we can classify and categorize stressors. So, one big stressor that we might have is a catastrophe, a large scale, unpleasant event, an earthquake, a house fire, a flood, a hurricane, right? So a lot of natural disasters or just really large scale things that you have no control over that have a really detrimental impact on your life. We also have our significant life changes, personal events, life transitions, getting married, getting divorced, having a baby, moving, right? These are all things that could be good in some cases, but still cause us significant stress. We, of course, have our daily hassles. These are the things we think of most when we think of stress. The line at Starbucks was too long and it's going to make you late for work. The train is stuck on 5th Street again, and you're going to be late for work, right? So again, things that aren't necessarily the end of the world, you'll get through them, but they still activate that stress response, right? And they build up and they add to things throughout your day. And then we have our social and our cultural stressors. So people who live in poverty, who aren't sure how they're going to pay their bills or feed their kids that day. People who maybe feel that they are of a lower social status compared to their peers. People who are a part of a group that feel discriminated against. All of those things cause stress throughout our day because we're aware of them, and that impacts things like our self-esteem and how we feel. So all of these challenges are what we're really looking at when we're talking about stressors. Now, we're going to talk about the stress response and how our body reacts to this. And you need to first understand what our body is deviating away from. So what we're deviating away from in the stress response is allostasis. Allostasis is kind of where you are at a happy medium for the circumstances that you're in. You've probably heard of homeostasis. You might be wondering, what's the difference between homeostasis and allostasis? So homeostasis is the idea that there's like a set point for everything that you should be at, right? Like your body temperature should be 98.6. Any deviation away from that is not good. Your blood pressure, right? If I ask you, what's a good blood pressure? Oh, 120/70, that's a great blood pressure. Absolutely. But a homeostasis doesn't take into account the different circumstances in which we find ourselves. 120/70 is a great blood pressure for sitting in your doctor's office. If you're running a marathon and your blood pressure is 120/70, we might have a problem. That's not a good blood pressure to have. Allostasis is the idea that your body has good values that are going to deviate along with the situation. So your stress response is any deviation away from allostasis. So the stress response is essentially the mobilization of energy to help you combat that challenge. If you've ever heard of the fight or flight response, that's your stress response. Your sympathetic nervous system gets activated. This is your response to a challenge. Am I going to fight it? Am I going to run away from it? Am I going to freeze and not do anything? All of that is the fight or flight response, and that's just what the stress response is. Now, the response to that threat, it could be a physical threat to you. You go up into the mountains and a bear comes at you, or a moose. That's a physical threat. We need to be afraid of that. It can be a psychological threat. I tell my students, best example to give students for a psychological threat is an exam that gets passed out to them. That is a threat to them. That is the biggest challenge that they will have that day. And it can be an actual threat where there's something physical or psychological in front of you right now. But sometimes we get a stress response from expectations, right? Something that we know is coming down the line, and we feel very stressed about that. So the stress response can occur in result to any of these. So what we're really looking at is the stress response in reaction to a physical challenge. A great example to really understand how necessary the stress response is to look at a fairly rare disease called Addisons disease. People with Addisons disease cannot produce certain hormones. Specifically, their adrenal glands will not produce cortisol. And you might think, well, that's great. They can't be stressed. But we need that stress response. When we are faced with a physical challenge, we need our bodies to rally, and we need our heart rate to increase and our lungs to relax and take in more air and all of these hormones to be released so that we can face that challenge. If someone with Addison's disease is in a stressful situation like a car accident, their bodies are not equipped to deal with that stress, and so they will literally go into shock. They don't have the ability to produce those hormones that we need in order to combat that stressor. Now, that being said, most of the stress-related diseases that we talk about and that we think about are related to psychological stress. It's an excessive response to a psychological stressor, because our bodies are pretty well equipped where we have evolved and adapted to respond to physical stress. We're pretty good at it. We are not at a point yet where we have gotten good at the psychological stress because we haven't had enough practice with it. All right. Sorry, I don't know where that's going. So it's fundamentally important that we understand this relationship between stress and our health, because really our stress is killing us. And I'm going to give you some examples as we go through today about how certain diseases that we consider just to be completely medical in nature are actually very much influenced by our psychological perception of stress. So what we need to really look at here is not just the stressor, what is causing the stress, but it's our response to the stress, because our response to things that are stressful can be more damaging in the long run than the actual stressor. If you can reorganize in your mind how to react to that, you will not have as much of a response. Okay, so we're gonna look at types of stress, and there's a couple of different types that I wanna break out in this subdivision. There we go. All right, so I wanna talk about positive and negative stress. Fancy terms for this in the world of psychology: eustress and distress. So positive stress is eustress. And we get confused by the term positive stress because we think, how can stress be positive? But remember, the fight or flight response is just designed for anything that challenges us. And good things happen that are still challenging. Having a baby is a wonderful thing. I hear it's pretty stressful. Getting married, going to school, moving to a new home, right? These are all really exciting, wonderful things, but they are stressful, right? They cause us to be challenged. However, these type of stressors are usually really positive and they give us energy, right? We're excited about tackling these challenges. They are typically very temporary. They're short-term. We can see an end to the stressful situation. It often improves our performance, and it's something that we can look at and say, I can handle this. I am equipped to deal with this. So that's positive stress, and it's really beneficial to us. Distress, negative stress. These are things that feel unpleasant. We don't like them. They deplete our energy. They make us feel tired. These can be short-term or long-term, either one. And typically we look at these and we say, I can't handle this. It's just not possible. And we feel very overwhelmed and we're likely to give up. So we have positive and we have negative stress. We also have acute stress and chronic stress. Now, acute stress, this is what we're designed to do. We are designed to deal with this. Imagine, we'll set the scene. You're on the savannah. You're a zebra. You're grazing, everything's right. You're in allostasis, right? I mean, everything's great. You're grazing on the grass. You're with your herd. Everything is great. And then you see a predator in the near distance. Immediately, your brain, your body is designed to go into fight or flight. Your heart rate will increase. Your pupils will dilate so that you can take in more light and see that predator better. Your lungs will relax so that you can hyperventilate, take in more air. Your circulation will increase so that blood can get to your limbs for fight and flight. Right? You're going to stop digestion because you don't need to digest your grass right now. You need all that blood flow in your legs so that you can run away from this predator. We are absolutely designed for these kinds of physical challenges, and they are very short-term. As soon as you escape or don't escape, your sympathetic nervous system will end, right? And your parasympathetic, that rest and recover state, will take over. So absolutely, we are not zebras, but we do, from an evolutionary standpoint, come from surviving predators out on the savannah, right? That's what we have been designed to do. So acute stress, just that sympathetic nervous system activation, we're good with that. I mentioned this before. We have not figured out the chronic stress thing. We have not adapted yet from an evolutionary standpoint to deal with the amount of emails in our inbox, the phone calls that we have to return, the bills that need to be paid that you haven't opened that are sitting on the table. Right, all of these things that just cause us this excessive stress that's psychological in nature, because there is not a leopard coming for us, nothing is attacking us, but we feel the expectation of all of these things on our to-do list, and that causes the same stress response as the actual predator attacking us. But instead of it ending after a brief chase, it just keeps going. You lay awake at night worrying about your to-do list, and your sympathetic nervous system says the leopard is still here. I still have to be panicking about this, and you still keep pumping out all of your stress hormones, and it continues to cause this chronic damage. All right, so let's look at some of these physical effects of stress. I want to talk to you about stress hormones. I took a class in college over 20 years ago, which is very stressful to admit to you. But it was called, I remember the class was called psychosomatic illnesses. That's what we used to call, illnesses like hypochondriasis and stuff. Anything that was like an illness that was physical, but it was caused psychologically, that's a psychosomatic illness. So that was the whole class, was called psychosomatic illnesses. And I remember, the memory is a funny thing. I can picture the building it was in. I remember the classroom was at the end of the hall. I remember where I sat. It was next to a window. I remember the professor, Dr. Neal. If you ask me what I learned in that class, all I can tell you is glucocorticoids. That's the only word I remember. What about them? I don't know. I just remember that we used to like tally mark how many times Dr. Neal could say glucocorticoids in one class section. It was a lot. So the point of the story is when you're talking about stress, psychosomatic illnesses, psychological stress, it's all about the stress hormone, glucocorticoids. So I want to show you exactly how the release of these hormones work. So this is called the HPA axis, hypothalamic pituitary adrenal axis. That's just a fancy way of telling you what order this happens in. So if we were to do a cross section of the brain, take the brain, cut it down the middle, and look at just the cross section. If you look kind of in the center, this is where your hypothalamus can be found. I'm going to use the cursor here. So here is your hypothalamus. And then this little stalk that comes down right here, that's your pituitary gland. So hypothalamus controls the pituitary. Pituitary is your master gland. It tells all of the other glands in your body, in your endocrine system, when to release hormones, when to stop releasing hormones, how much hormone to release. That is the pituitary's job. And so when you are facing a stressful situation, hypothalamus tells your pituitary, what's going on. We are deviating from allostasis. You need to do something. Pituitary will go down to your kidneys. And on top of each of your kidneys, you have a cortex called the adrenal cortex. And that adrenal cortex releases adrenaline, right? Adrenaline. All right, so that is the HPA axis. Basically what you're looking at is the paraventricular nucleus, if you care, of the hypothalamus releases a hormone called corticotropin releasing hormone. Its job is to then stimulate the pituitary gland to release another hormone called adrenocorticotropin hormone. That goes down to the adrenal glands, and the adrenal glands release all of your glucocorticoids. In humans, the most common glucocorticoid is cortisol. So you're going to see a big release of cortisol that will give you your stress response. Now, you have a naturally built-in feedback system because, again, this is built for physical temporary challenges. A leopard is chasing you across the savanna. Once that is done, we need some kind of feedback system. So the adrenal glands with those glucocorticoids, they will go back to the pituitary and the hypothalamus and say, okay, we got the message. You can stop sending the instructions to release the cortisol. We've done it. It has been released. The problem with chronic stress is that it doesn't matter how many times you go back and tell it to stop, you have more stress coming in and sending more signals. And so you just get more and more of that stress response. Okay, so we're going to look at the stress response, and we're going to talk specifically about how it affects how often we get sick. So the immune system, this is called the general adaptation syndrome. It comes from Hans Selye. kind of a oversimplified, I think I'm getting double feedback and that's why. It's an oversimplified look at how the immune system deals with this, but it's a good example. So what we're looking at here is time across the bottom. So as time goes on, with my students, I always talk to them in versions of like semester, right? So the fall semester starts, everything's great, you're in homeostasis, you're happy, everything is just wonderful. And then as time goes on and stress builds up, everything goes horrifically wrong, right? So this is what we're looking at. Going up here on the y-axis, this is going to be our level of immune resistance, meaning if someone comes and sneezes in your face, what's the likelihood that you're going to catch that cold and get sick? If you are in good health, if you are in homeostasis, your immune system, it is ready for you. It has a job to do, and that job is to find invading viruses and bacteria and cancer cells. And its job is to immediately destroy them so that you never have to feel sick. And in times where you are feeling good and you're not overly stressed, you're going to be fine. Anyone can sneeze in your face, you're going to be just fine. Then when you're stressed, everything goes wrong. So when we start, we get through, the first part of the semester, that's when the first test comes due. Right? So, or if you're dealing with your job, a big project comes due, something happens in your life that challenges you. And what you're going to see right away is a little dip in your immune system. You're a little less resistant right now to any viruses, bacteria, things that might happen. So you're a little more at risk, but your immune system will rally and it will say, okay, challenge accepted. We obviously need to produce some more T cells, B cells, macrophages, right? All of these different things, we will just increase those and we are ready to deal with these challenges. And so actually this is a good thing. This is why I tell you, you need some stress in your life because you will actually increase your immune resistance that will go up. You will be less likely to get sick when you are under a moderate amount of stress. The problem comes when that stress continues, you don't manage it using the strategies I'm going to share with you later today. And eventually you hit this third stage of exhaustion. Your immune system will run out of resources. If you don't give it time to rest and relax and rebuild all of those antibodies and B cells and T cells, then it will run out of those resources and you will crash. And this is where we reach the end of the semester when I get all of the emails from all of my students that they are in bed sick and cannot come to class because they did not cope with their stress throughout the semester. And it's classic. I mean, I tell them that's what I did. I planned my Christmas break in college around being sick. Like I would just call my mom and she'd be like, what do you want to do for Christmas? I said, well, it doesn't matter. I'll be sick. And she's like, oh, you're sick? Well, not yet. It will be once I finish finals. So that's kind of the general adaptation, right? So if we can figure out how to stay in either stage 2 or even back here in stage 1 or homeostasis, that would be ideal, right? So it's not like it's, a given that you'll hit exhaustion stage, but most of us do because we don't know how to manage our stress. Okay, so when our immune system is not functioning properly, there's 2 different ways that it can be in dysfunction. So it can either underreact or it can overreact. Now, underreacting, we're very familiar with. If you've ever been sick, you're familiar with an underactive immune system. So you fall, you cut your knee, you get a scrape. If you are undergoing a lot of stress, that is going to delay your healing time. It's not going to battle the bacteria as well. It's going to get infected. So that's part of your immune system's job, is to battle that bacteria. Anybody know what that virus is? I bet you don't. This is the herpes simplex virus. Aha. Yeah, I know, I fooled you. It is spiky though. If you've ever had a cold sore, you are familiar with the herpes simplex virus. If you have herpes, the herpes simplex virus, this often lies dormant within us. We can never really get rid of it. It's like chickenpox, shingles, Epstein-Barr, right? Some of these viruses, once you have them, they are with you forever. You cannot get rid of them. And when you are undergoing a stressful time, they pop up because your immune system is out of resources. When you are so stressed, You run out of resources and your immune system says, I cannot control this virus any longer. And it's always at the most inopportune times. And that nasty little cold sore just pops up for you. And it's because you're stressed. All right, cancer, more likely to multiply when you are undergoing a lot of stress. Stress does not cause cancer, obviously, but you have these natural defenses within your immune system whose job it is to patrol your body and look for malignant cells that are multiplying faster than they should be, and it kills them, squashes them before they can form a tumor or anything like that. The more stress you're under, the less ability your immune system has to go find those cancer cells. All right, so stress itself doesn't make you sick. What happens if you're looking at a psychoneuroimmunological approach, you encounter a stimulus that causes you stress. Sorry, I can't see this now. You turn your stress response on, and then that releases glucocorticoids. You should count how many times I can say it in a session. And then your stress response, how long it is and how strong it is going to determine your immune functioning. And really what happens when you get sick is it's just your immune system no longer being able to function at an optimal level. So stress doesn't give you a cold, it doesn't give you a virus, it doesn't give you a cut, it doesn't give you cancer. But if your immune system is not able to properly mount its defenses, then you're going to have more disease. Okay, the 1940s, late 1940s, England, the war has just ended. You're a medical researcher and you say, I want to know if stress makes colds worse. So you set up a resort out in the country, Salisbury, England, and you are going to pay people to come stay at your resort for 3 weeks. They show up, you're going to give them a stress survey, see what their stress levels are out starting out. And then the people know, like, they're getting paid to do this, all expenses paid. We're going to give you money, we're going to give you food. All you have to do is lay around and be on vacation for 3 weeks. But after you take your survey, we are going to spray rhinovirus, common cold, up your nose. And we're going to just see if you get sick. But we'll pay you. They did this project for 45 years. This was like a huge project that it was called the Common Cold Unit. Like, they should make a TV show out of this. But what they did is they compared then the people who scored, really high on their stress surveys versus really low, who got sick, who didn't. And of course, there was a control group that just got saline sprayed up their nose, just to control for that. But the people who were the most stressed were 3 times as likely to succumb to that common cold after being exposed to that virus. The more prolonged their stress was, if their stressors that they reported on the survey were a month or more, and especially if that stress was social in nature, they were more likely to get sick. All right, now the other way we could go with the immune system is overreacting. So allergies, anyone? Seasonal allergies, yes, or so pollen, cotton, dander, right, pet dander. An allergy is just your immune system overreacting. It's an autoimmune response. It's your immune system being overly dramatic about the pollen that gets into your mucous membranes, right, or the dander or whatever it might be. So allergies, asthma, any of that is your immune system just going overboard. I want to talk to you a little bit, though, about autoimmune diseases, because they pose an interesting question to the glucocorticoid stress relationship. Because with autoimmune diseases, rheumatoid arthritis, diabetes, type 1 diabetes, lupus, multiple sclerosis, narcolepsy, all of these are examples of autoimmune, meaning your immune system, whose job it is to patrol the body and attack invaders, gets bored. No, it gets a miscommunication, and it begins to attack something of you. So multiple sclerosis, it decides myelin, the covering of the axons in your central nervous system. This is an invader, shouldn't be here. I'm going to kill it, and it destroys your myelin. You need your myelin. Otherwise, you get the symptoms of multiple sclerosis. Narcolepsy, falling asleep, being tired all the time. Your immune system begins to attack neurons in your brain that release a hormone called orexin that keep you awake during the day. And we don't really know why the immune system just begins to attack different parts of your body, but it does. So that's autoimmune diseases. Now, if you know someone with an autoimmune disease, you may know that in order to treat it, we often throw a lot of steroids at them. And steroids are synthetic glucocorticoids. So we just give you a whole bunch of glucocorticoids to bring your immune system back down. We want to weaken your immune system. Okay, great. That makes sense. Your immune system's overactive. We give you glucocorticoids. It brings it down. Couldn't you then just say that stress should make you feel better? Like, shouldn't we just stress you out and then you'll release your own glucocorticoids and then you'll feel better, right? I mean, that makes sense. It's a good relationship. And actually in lab rats with autoimmune diseases, if you expose them to prolonged stress, it does improve their autoimmune symptoms. If you've ever talked to someone with an autoimmune disease, or if you have one, you know that stress does not make it better. Stress makes it much worse, right? It causes your symptoms to be exacerbated. So why is that? Well, let's go back to Cellier's model. So if you remember, in a normal person without autoimmune disease, we reach a point with the immune system where it runs out of resources and you go into the exhaustion stage and you just burn out. Well, let's add something to our graph here. Let's add a range on top. What if we could keep going up in our graph? And we're going to add a range where if you hit that range, you have an autoimmune disease and you begin to have your autoimmune symptoms. Instead of giving up, instead of our immune system crashing right here, what if it were to keep going? What if we had so many little numerous transient stressors that continue to add up that instead of giving up, it just reaches up into that autoimmune disease range? Stress is often a trigger for the onset of autoimmune diseases. And of course, once you have an autoimmune disease, stressors like this continue to make those symptoms worse. So we call them flare-ups, right? Where we don't feel good, our symptoms are exacerbated. So why does it work in a rat and not a human? Because we're more complex? No one knows, right? But we do know that stress will make your autoimmune disease much worse. All right, now the immune system is directly regulated by your metabolism because metabolism gives you energy. Your immune system needs energy in order to operate. So I want to talk to you a little bit about metabolic dysfunction, things like your blood sugar not being well regulated, diabetes, weight loss, weight gain. A lot of people get a redistribution of fat right around their abdomen, which is a high risk factor for things like cardiovascular disease. So what I want to show you is kind of how we derive the energy and how stress impacts this. So we're going to talk about things that we eat and how that affects what's in our blood circulation. I'm going to focus on carbs because when we're stressed, all we want is carbs. Have you ever wondered why that is? Because carbs give us glucose and we need glucose for energy, right? If I'm a zebra out on the savannah and I need to run away from a leopard, my body needs glucose. That's where I get all of my energy. That's where my cells are going to use and store energy. I need glucose. So from an adaptive perspective, it makes sense that when our bodies say, I'm so stressed out, I need more energy, go eat sugar, go get bread, go get whatever, whatever it is you want to derive your carbs from. But that's why we crave it. So in our bloodstream, it's glucose. When we have enough of it, we store it in our liver as glycogen. And then when we need it back again, there's a lion coming at us or whatever, then we use it as glucose again. So we take it back out of the liver, we take that glycogen and we convert it back into glucose. So it's this constant process of we eat something, we break it down into glucose, we store it in the liver, we take it back out of the liver and we use it as glucose. All right, so that's the whole process that occurs. The problem that happens with this is when we begin to experience chronic stress, stress after stress after stress, we are continuously putting glucose in storage and then taking it back out and then putting it back in and then taking it back out. And every time we do that, it uses more energy. So you're using energy to store energy and to use energy. So you're using it more. So you're penalized for having a lot of those transient stressors that occur over and over again. The other thing to keep in mind is glucocorticoids. So when you have your stress response, it blocks the ability of your fat cells and your muscles to use glucose. So you are needing all of this energy and your brain is saying, go eat something because we need energy. But because you're so stressed, you're not actually efficiently using that energy. It's just getting stored and stored and stored, and you're not using it effectively. The other thing that happens is insulin resistance. So I want to talk to you a little bit about the process of how insulin works. And I focus a little bit, I spend a little bit of time on this with diabetes because it's becoming a health crisis. And it's not just related to what we eat, it's related directly to our stress levels. So when we eat something, we're going to start right here in this corner. Every time you eat something, you get an increase in blood glucose naturally in your blood circulation. Your hypothalamus is regulating that, detects that we have more glucose in our blood, tells the pituitary tells the pancreas, we need insulin. Insulin is the hormone that allows our cells to use glucose. If you do not have insulin, you can eat all the sugar you want. You can have blood glucose up the wazoo. Your cells cannot use it. I tell my students, think about glucose as like a kindergartner who wants to go to the cell, but it needs insulin to hold its hand to get in, right? So it needs help getting into the cell. So if you don't have insulin, you don't get to use that energy. But in a normal person, your pancreas is going to create insulin just fine. So you're going to have an increase in blood glucose, increase in insulin in your blood. That insulin is going to help glucose be used by the cells. And then once the cells that need it have enough and they're using it, then any surplus you have gets stored away in the liver. Once the liver is full, we make fat tissue, right? Adipose. All right, and then your blood glucose naturally is going to decrease because all the glucose is inside the cells. It's no longer floating around in the blood. Your insulin will then decrease and then eventually you feel hungry and you eat again, right? So it's this big cycle. So the question then becomes, what if we don't have insulin? So what if diabetes is preventing us from having this? All right, so there's two types of diabetes. Type 1, also known as juvenile diabetes. We usually see this in kids. It's an autoimmune disease. This is insulin-dependent diabetes. This is caused by the immune system deciding, I don't like the pancreas. That's what I'm going to decide to attack. And it doesn't allow the pancreas to release hormones. So because of this, the type 1 diabetic eats and eats and eats. They have all this glucose. If they're not injecting themselves with synthetic insulin, their cells are starving. They do not have any access to the glucose they are eating. So as a result, they have all this free-floating glucose and fatty acids in their blood circulation with nothing to do. We'll come back to that. Your type 2 diabetics. These are not insulin dependent. This is insulin resistant. Type 2 diabetes is a disease of inactivity and fat surplus. So this typically occurs as a result of gaining too much weight, having too much fat in your cells as an adult. So when you hit adolescence, you have as many fat cells as you will ever have. Your fat cells do not continue to multiply. They just expand. So as you add more and more fat to that, as you continue to eat and your cells are full of the glucose, you store it as fatty tissue, but you don't add any fat cells. You just increase the size of them. And eventually those cells in a given day get full. They cannot put any more in. And so insulin, your pancreas keeps releasing insulin saying, oh, I've got all this glucose. I'm here to drop it off at, glucose kindergarten, however you want to imagine it. But eventually, because those cells are full, they stop answering the door to insulin. They're like, no, we're full. We don't want you anymore. So they stop responding to insulin altogether. And you develop type 2 diabetes. Your pancreas just says, okay, then I won't make it anymore. And now you don't make insulin anymore. So again, you eat all this glucose, and if you're not injecting yourself with insulin, you have free-floating glucose and fatty acids in your bloodstream. Why do we care about that? Because free-floating glucose and fatty acids degrade the lining of your blood vessels, which results in cardiovascular disease, stroke, high blood pressure, blindness, chronic pain, all things that we don't want to have happen, right? How does this relate to stress? Our friends, the glucocorticoids, increase the amount of glucose and fatty acids present in the bloodstream, and they instruct the fat cells to be resistant to insulin. Now, I bring this up not as a way to lecture you about your eating habits. I don't care what you eat at home. We are finding more and more people being diagnosed diabetic at a healthy weight. And it is not what they eat that is causing diabetes. It is their stress levels. It is the glucocorticoids from chronic stress that are causing that increased buildup in glucose and fatty acids, degrading their blood vessels and causing all of these issues. So stress itself, we're finding, and this is just the last couple of decades, we're finding this, stress can lead to diabetes. It's not necessarily just about autoimmunity or weight gain or anything like that. All right, so I mentioned cardiovascular disease. This is kind of an interesting one because this is where we start to go in a little bit of a circle. Stress, glucocorticoids, causes increased blood pressure. When you increase the blood pressure, the small vessels of your cardiovascular system respond by building a thicker muscle layer, right? So that they can respond to the increased blood pressure. Well, when you build a thicker layer of muscle around the vessel, that makes it more rigid. And so in order to pump blood to the heart, you have to increase the flow. You have to increase your blood pressure. And when the vessels have increased blood pressure, they build a thicker wall, which makes them more rigid, which means you need more blood pressure. Are you seeing the problem with this, right? So this is going to go in a very large circle. So stress, high blood pressure, is what's going to eventually lead to cardiovascular disease. All right, so if we were to dissect a heart vessel here, when we are looking at increased blood pressure, all of that pressure pushing against the vessels constantly begins to wear and tear at the lining, like a hose that you overuse in your garden, right? Over time, you've got to replace the hose, it gets holes in it. So when you get damage to the lining, a few different things happen. You're going to get immune cells that immediately go to that site to try to repair it, and they're going to conglomerate all right there. They're going to form a little accumulation. You're going to have epinephrine released during stress, which is going to cause platelets to clot, to clump, all right there. They'll kind of join the immune cells. You've got all kinds of fatty acids and proteins just floating around, and they say, this looks like a great place to hang out. We'll just stay here too. And now all of a sudden, you've got an atherosclerotic plaque, which is essentially a clogged artery. Could lead to heart attack, could lead to stroke, right? Depends on the location of where this is happening. But here's the kicker. Chronic stress is a bigger predictor of high blood pressure and these atherosclerotic plaques than high cholesterol. So if you're at home counting how many eggs you eat and rationing your butter and your red meat, I don't care. You need to reduce your chronic stress because that's going to be a better predictor of your heart attack compared to what you're actually eating. Now, if you combine chronic stress and a bad diet, then yes, you are just putting yourself at a huge risk for cardiovascular disease. You may have heard that men are more prone to cardiovascular disease compared to women. This is a finding that has been, shown across medical science for as long as we've been studying it. And we have recently found it's because estrogen has a protective benefit to women. More estrogen means it actually prevents these atherosclerotic plaques building up. It does not reverse them. So if you have a woman that has really clogged arteries, you can't just pump her full of estrogen and make it all better. Once they're formed, they're formed. But it helps to prevent their formation. But in the last 20, 30 years, the frequency of women having heart attacks has been creeping up. Why would that be? Do we have less estrogen? No. Stress suppresses the effects of estrogen and its protective effects. So that is why we are seeing women become just as likely to have heart attacks as men now. All right, mental effects. Let's talk a little bit about the perception of pain. Pain is something that we really need. We need to know when we're in pain. Imagine you walk out, you fall on the ice, you break your leg, you have no idea because you don't feel pain and you just go about your life. Not really a useful thing, right? We need to feel pain. Pain is useful. There's two types of pain receptors that we have. We have these really fast, small fibers that send that sharp piercing pain, like when you stub your toe, right? You get that immediate sharp stabbing pain. But then we also have the dull throbbing pain that lasts for a few hours or days or months, whatever it might be. Those are like the slow fibers. And both are important because even after I've fallen and broken my leg, my body still wants me to remember that it's broken so that I'm careful with it, right? That's the point of pain. That being said, some people experience pain and there's no real reason for it. Migraines, fibromyalgia, neuropathy, right? These are all pain, but we can't do anything to modify it. At this point, pain is not helpful. It's just debilitating. So there's two different areas in the brain that process this. We're going to start with the one on the right, your somatosensory cortex. This is the part of the brain that is mapped to your body for touch sensation. So if I stub my pinky toe, there's a little subset of neurons. I'll just pick, like right here, for example, and those neurons are mapped to my pinky toe. So it knows, so that cortex will be active when something touches my toe, when I stub it, when something happens to it. It lets me know this is where the source of the pain is coming from. That's how you know that you stubbed your pinky toe. The other part of the brain that also acknowledges pain is right here, the anterior cingulate cortex. This is the part of the brain that does emotional regulation. It also does empathy. So some people with really strong empathy, if they see someone else stub their toe, they feel the pain, right? Or we can imagine, that hurts, right? So that's the ACC, the anterior cingulate cortex. What we find with pain is that the amount of pain that you feel and how unpleasant it feels to you can be very different things. Imagine that you're stubbing your toe. If you are at home by yourself and you stub your toe, you are allowed to make as much of a deal of that as you want. You can curse, you can throw things, you can be angry, you can say, I need to sit down and watch Netflix for 2 hours and deal with this, right? But what if you stub your toe at work in a meeting where all your coworkers are? All of a sudden, that doesn't hurt, right? You squash it down, you grit your teeth, and then you move on and you distract yourself with something and you forget that you even stubbed your toe that day, right? That's the difference here. The somatosensory cortex got the same stimulus. Whether you're at home or at the office, it doesn't know, it doesn't care. It sent the same response, level of response to that cortex. But your anterior cingulate cortex said, this is not an appropriate time to feel emotional about that. So I'm going to ignore that pain, and then you get over it, right? So we've got two different areas working. Now, what does that have to do with stress? So stress can have two different effects on the body. You can have analgesia, where you don't feel pain. We hear this a lot with like combat soldiers out on the field, right? They've been shot, something is broken, all of these horrible things have happened, and they get to the field hospital and they say, I'm fine, I don't even feel it, don't give me any morphine. And they're like, but literally like your intestines are hanging out, so maybe a little morphine. They're like, it's fine. Stress blocks pain. Physical stress, acute physical stress will block your ability to feel pain temporarily until the immediate danger is gone. But in some cases, stress can cause hyperalgesia. Hyperalgesia, again, things like fibromyalgia, neuropathy, things like that, where you feel pain and there's no reason for it. You've all felt this at some point. You get a cut or a burn, and not just that area of the cut hurts, but the whole area around it, right? You get a nasty cut, and you could be 2 inches away, and you touch that, and it's really sensitive, and it hurts, right? That's hyperalgesia. You're overly sensitive to something. But some people experience that kind of pain where their skin just hurts to touch, and we don't really know the reason for it. What we do know is that your emotional reaction to it is going to mediate just how painful that seems to you. So the anterior cingulate cortex, if you are upset about your pain, if you're someone with fibromyalgia and you're like, this isn't fair, I hate this, I don't know how to handle this, that emotion is going to make the pain seem even more so than it would in someone who is able to better manage that emotion. All right, I'm running out of time. You're all shocked, I know. But I'll just go through this really quickly. So your memory, your ability to remember things under stress, kind of an interesting dichotomy that we see here. So again, we're looking at glucocorticoids, fight or flight syndrome. We know that we're going to increase the amount of glucose in our blood, and we're going to increase our blood pressure so we can get glucose up to our brain. So when we're doing that, we're also going to end up giving ourselves a memory boost. Think about it. When you are stressed, it's a great time to be able to remember things. Where have I seen this problem before? How did I solve this last time? How am I going to remember how I solved it this time so I can solve it next time, right? So that acute stressor is a great time to have a good memory. So here's kind of what we see. A moderate amount of stress, short-term stress, I should say, moderate short-term stress gives you the best memory boost. As you continue to experience prolonged stress, that's going to decline. But you can also see here, and again, this is just like a traditional bell curve. If you don't have any stress, your memory isn't as good either. So the best way to remember things is to give yourself a little bit of stress. It can be eustress, it can be good stress. It could be exercise, right? But in some way, engaging that sympathetic nervous system, fight or flight, will actually give you a boost in memory. The type of memories I'm specifically talking about are your explicit memories, facts that you have learned, personally experienced events, things like that. That's what we're looking at in terms of memory. Okay, just want to show you. It'll load. Here we go. Okay, this is a time-lapse video over 7 days. These are neurons connecting in brain tissue. So anytime you are learning something, anytime you are recalling a memory, anytime your neurons are communicating with each other, they are constantly reaching out to their neighbors. Every neuron connects to 1,000 other neurons. You have 100 billion of them in your brain. They are constantly reaching out. They are forming connections. They are deciding, do I want to stay connected to you? Do I not? And they are just continuously moving. Your brain is a living organism. And I think we kind of forget that sometimes. But if you have enough stress and glucocorticoids can interfere with that, you're going to have some problems. All right, so memory occurs in the hippocampus. We called it the hippocampus. You have two of them. You have one on each hemisphere. So you have a right hippocampus, you have a left hippocampus. And then, if you're looking at a side view, this is what it looks like. Hippocampus is Latin for seahorse. Can't really tell in the picture, but if you actually take out the hippocampus, it looks like a seahorse. But what we find in terms of effects of glucocorticoids is that the more glucocorticoids you have from a stress response, the more it activates your brain's natural adaptive response to forget things. Because we need to forget. You don't want to remember every single thing you did during the day. We need to forget things. But if you have more stress, you will forget more things, including things you might not want to forget. We see a decrease in the brain's ability to form new neurons. The hippocampus is one of 2 areas of the brain that can actually form new neurons throughout your life. The other one is your olfactory bulb for your sense of smell. But the hippocampus forms new memory neurons throughout your life. But if you have too much stress, it will impede your ability for neurogenesis. There's also some evidence that it will increase the amount of cells that are killed in the hippocampus. So glucocorticoids will actually destroy cells within the hippocampus. And in certain cases, there's evidence that suggests that you have a reduction of volume in the hippocampus. So the actual structure reduces the amount of tissue that it has. We find evidence of this in combat veterans with PTSD, as well as children who underwent significant childhood trauma who have been diagnosed with PTSD. Now, I will say the issue with those studies is that they are correlational. We don't know if those PTSD patients have a smaller hippocampus because of the trauma, or if because they had a smaller hippocampus, they were more likely to develop PTSD. Right? So we don't know the direction of causality with that, but we do see that it is a potential to have reduced volume in the hippocampus. But really what we're looking at here is stress, which is prolonged exposure to glucocorticoids, can cause both structural and functional changes in that hippocampus. And those changes may very well be long-lasting or even permanent. All right, sleep. Not getting enough sleep is very stressful. And when you're stressed, you can't sleep. Yes, this is a very large problem that you're all nodding along with, like, yes, that is an accurate depiction of my life, Rachel. So typically, you want to get a nice good 8 hours of sleep. Yeah, I know. I'm with you, Megan. All right. So this is what you want it to look like, right? You want to be awake, and then you're going to go through all of these nice little light stages of sleep. You're going to have a cycle of deep sleep. You're going to come back up out of that. You're going to have a REM cycle, which is your dreaming sleep. Then you'll go back down, and you're just going to cycle through this. You're going to have shorter and shorter deep sleep as you go. We're going to not have as many stage 4s, but you're going to have longer REM as you go along, right? So that's the ideal, right? Doesn't happen for any of us, but that's the ideal of what you want to have. Sleep is a natural time where you have no glucocorticoids being released. There's no stress response while you're sleeping because there's no predator chasing you, right? There's nothing happening. So this is a great time. This is where your body can really restore itself and relax and not have any stress hormones. So the less you sleep, the less time you have to remove those levels of glucocorticoids. So you're sleep deprived, you have more higher levels of glucocorticoids, which again brings us to that cycle of too much glucose, too much fatty acids, degenerating the vessel linings, heart attack, etc. If you have to choose of how little sleep you're going to get, you have two choices. Let's say that you only have 4 hours in which to sleep during the night. So do you want to sleep all 4 hours at once, continuous, uninterrupted, but not enough of it? Or are we going to spread that out? Sleep for an hour, get up and do something. Sleep for an hour, get up and do something. Okay, the second one, don't do that. That's very bad. If you have to pick one, get the continuous sleep, because the more you are waking yourself up, the more you are causing a stress response on your body, and you just keep building those glucocorticoids, right? This is terrible news for new parents, right? Because your baby's going to wake you up throughout the night. That's part of the stress, right? All right. Good news and bad news. Good news is I'm going to pretty much skip this, but it was planned, because if you asked me, does stress make mental health disorders worse? Yes. That's just the flat answer. Whatever disorder you have, pick one. And this is not all inclusive by any means. Yes. That's a lecture all on its own. I don't have time for that. Happy to answer questions about it afterwards by all means. I thought about talking about at least depression and anxiety. I think by now you have caught on to the fact that glucocorticoids harm you. That's all I remember from my class, right? All right, quickly, we will go through strategies. Personal control, your perception of the control that you have is very important. When we feel that we have no control over something bad that has happened, it activates that stress response. And eventually, if we don't feel we can get control over it, we develop what's called learned helplessness. Think of learned helplessness as when you just feel so overwhelmed with your to-do list that all you want to do is curl up in a ball and not do anything. Yes, that is learned helplessness, essentially. Animals do this, humans do this. It is a very common way of looking at things. So when you have this perceived loss of control, you activate your stress response. Glucocorticoids increase, blood pressure increases, and your immune responses drop. So if you can give people a sense of control, you'll actually have better health outcomes. This has been studied in certain populations where a loss of control has actually resulted in very poor health outcomes. So if you look in prisons and nursing homes, that's two things that shouldn't be related, but unfortunately are, right? So prisons and nursing homes, you have horrible health outcomes and astronomical medical expenses for all of these places, whether you're looking at doctor's appointments, medicine, things like that. And what these researchers started looking at was like, okay, well, why are we seeing so much so much disease, so much infectious disease spread, all of these things happening in these environments. Yes, they're enclosed, but why are we seeing this? And if you think about it, in a prison and a nursing home, depending on which one, what type you're in, you have very little control over the decisions that you have during your day. You are told what time to get up. You are told what and when you are eating. You are told when you are showering. You are told when you get to go outside. You are told what movie you are watching today, and you get no choices. As a result, they have learned helplessness. They have no immunity. They are stressed. They have a stress response all the time. So these researchers went into a select few prisons and nursing homes, and they said, give them some choices. What do you want for breakfast? What game do you want to play? What do you want to watch on TV? When do you want to go outside? Just give them some choices. Amount of disease dropped, prices for medication dropped. It worked out well. So giving someone personal control helps their stress response quite a bit. Now, make sure you don't give too much because choice overload becomes a problem. If you've ever been on Netflix, you are aware of choice overload because you will spend more time deciding what not to watch than you would had you just picked a movie and watched it, right? So that can also activate. So, if you're in a nursing home, you can't tell the residents, here's Netflix, what do you want to watch? That'll be too much stress. You give them 3 options. Which one would you like to watch? All right, now, the way you explain things that happen to you also plays a large part in this. So this is your personality. Now, you can't really control your personality. Your personality is your personality. You can control the choices you make, but we all have our personality. That being said, if you are aware of your particular personality type, you can still make different choices based on that. So we've got our pessimists and we've got our optimists. Pessimists always expect things to go bad, and we like to blame others for it. Everything bad always happens to me. The universe is out to get me. Of course this happened to me. See? There's no point in me even trying because it's just going to go bad. That's pessimism. They don't handle stress very well, right? Because they don't have a sense of control over anything. Optimists kind of expect just generally things are going to go pretty good, right? Everything's going to be fine. They work well under stress. Optimists have a longer lifespan than pessimists because of the stress response, right? They are less stressed than pessimists. Now, it's not fair because the optimists have a genetic advantage over those of us that are pessimistic. Optimists have a genetic marker that gives them higher levels of naturally occurring oxytocin in their bloodstream. So oxytocin is the love hormone, right? It's known as the cuddle hormone. So you get it when you have like good social connection with people. You get it from like a really good hug with someone that you love, right? So all those things build up oxytocin and make you feel good. And optimists, they just have more of it naturally. It's not fair. Pessimists have to go out and get oxytocin. We have to hug people, and we're pessimists, so we don't like to hug people. This is problematic for us. But if you know what your explanatory style is, if you know you're a pessimist, then you can go into a stressful situation saying like, okay, maybe I look at this a different way. Let's be positive about it, and then we can handle our stress a little bit better. Okay, I promise I'm almost done. Social support. The fewer the social connections you have with people, the more likely it is that you will have higher stress responses and you are more susceptible to infectious disease. Study after study has shown this to be true. And this is true no matter what your gender is. This is true across races, and it's true whether you live in an urban or a rural environment. Social connection is very important to dealing with the stress response. It is so important, in fact, that the impact of social relationships on your life expectancy is just as impactful as people who smoke, people who have hypertension or obesity, and it doesn't matter across level of activity. So social support is so important. If for the same given illness, pick an illness, right? People that have the fewest social connections have a 2.5 times as much chance of dying early compared to people with more social connections. And that remains true across gender, age, and health status. And again, I tell my students, it's quality over quantity. The number of Instagram followers you have does not count. So quality relationships that you have with people. And so social support, how does it work? Two ways. It calms your cardiovascular system, and it's going to fight illness by fostering your immune function. Interestingly, social support in the form of giving support is just as beneficial as receiving it. So it doesn't necessarily have to be that you need someone to come take care of you. You reaching out and giving support to someone else also reduces your stress levels. Also want to point out, it does not have to be humans. Pets are very good at this, especially if you don't like people, right? Pets can do this, and it doesn't even have to be fluffy. Pet turtles, a pet fish that sits on your desk, has been shown to reduce stress levels significantly in people. There was one study where having a cricket that someone had on their desk in a little thing gave people social support, right? So you don't even have to be able to like cuddle it or anything. Just a living organism that you can identify and bond with reduces your stress response. All right, exercise. I hate talking about this because I never follow it. It's the best way to combat your stress. I hate it, but it really is. My advice to you is to get more exercise. It works in a few different ways. So produces endorphins. These are your natural opiates. It feels good to exercise, not at first, which is why I don't like it. But once you get going, it releases endorphins, you feel better. Gives you a sense of achievement and self-efficacy. You feel good about yourself when you've accomplished that, right? And then also, it ends up in the end reducing tension. Your body is so excited that it's using fight or flight to actually fight or flee, right? This is what it's designed to do. This is what your stress response is meant to do. It's supposed to run away from the leopard chasing you across the savannah. So when you actually exercise, your stress response is like, thank God. It's so relieved, right? So it actually reduces all of that tension. And it's a healthy way of getting those glucocorticoids through your bloodstream. Now, there's a couple caveats to this. Exercise only blunts that stress response for a few hours after exercise. So you have to keep doing it several times a week. Also, exercise only reduces stress if it's something you want to do. You cannot force someone to exercise and say, this is for your own good. It'll reduce your stress. That's just going to cause more stress. So you have to like voluntarily exercise in order for it to be useful. All right, last thing I want to mention is mindfulness and meditation. If you are like me and the thought of exercise is just the absolute worst thing that could possibly happen to you, I recommend this as a way of reducing your stress. So mindfulness meditation, not everyone has heard of this. You've heard of meditation and you usually think of like, a monk, saying Om and doing yoga and things like that. But mindfulness meditation is where you have this focus and intense awareness of your surroundings, of your sensations and of your body and your feelings and your thoughts, right? So mindful, you are internally focused on what is happening with that. And what that does is actually influences your brain along two different pathways that are involved in attention and emotional regulation. And the more you practice looking inward and focusing on those sensations and feelings, the more you activate areas of attention and emotional regulation. So there's evidence that suggests that people who really practice this idea of mindfulness, they're better able to focus just on the present, which means they worry less about the future and they ruminate less about the past, which is something we all want to stop doing. So things that it helps with, mindfulness-based therapy has been effective at reducing stress, anxiety, depression. It can help people stop smoking, battle addiction, helps with pain and fatigue. It helps improve immune function. People who, in one study, underwent mindfulness meditation training were more quickly able to get over a cold. Again, we love spraying the cold up people's nose to see what happens. So yeah, I mean, basically, if you are able to incorporate any of these, but specifically all of them, if you can be mindful throughout the day, exercise 3 times a week, have a social support system, find ways that you can find personal control over the things that are stressing you out, you have managed your stress. And it takes practice because we're much more used to just giving up and having learned helplessness. So those are my suggestions at managing your stress. So I'm sorry, again, as always, went over time, but thank you so much for your attention and I'll take any questions you may have.